One of the things we're going to need to be able to do in order to balance equations is count atoms. So I thought I would put together this to help clarify how to count atoms. What we're doing with balancing equations is putting together a table where we identify the atom and then we count it as either a reactant or a product. I'm just going to say we're counting it as reactants at the moment. So what we do is we identify our atoms. I've got silicon, and oxygen, and what I want to do is count how many of each I have. So what I would do is take a look where the subscript would be. In this case, there is no subscript, so it's understood to be 1. So I have 1 silicon atom. And for oxygen, I have 2 silicon atoms. Let's try another example. In this case, I've got calcium hydroxide, and I'm going to identify my atoms. I've got calcium, Ca. I've got oxygen, O, and hydrogen. Oxygen and hydrogen make up my hydroxide ion. Notice I am not going to leave that together. I'm going to break it up into its pieces. It's oxygen and it's hydrogen. To count the atoms, again, I'm going to take a look at the subscripts. Here, calcium has no subscript. So again, it's 1. For oxygen, there's no subscript here, but notice I've got this 2 on the outside of these parentheses. Just like in math class, what I would do is I would distribute or multiply that 2 by everything inside the parentheses. So what we would wind up with for the oxygen is 2 times 1. Here's my 2. Here's my 1. 2 times 1 would give me a grand total of 2 oxygen atoms. And I would do the same thing for my hydrogen. Again, I have no subscript here, but there is that subscript outside of the parentheses, so it would be 2 times 1, again, to give me 2 hydrogens. Let's take a look at yet another example. Again, I'm going to count these as reactants. I could just as easily, they could be on the product side, it doesn't matter. I'm just counting. I would go ahead and identify my atoms. So I've got phosphorus, and oxygen again, and that's it. So now what I would do is count, and again I'm going to identify how many I have with my subscript, but this time, instead of another subscript outside of the parentheses, what I've got is I've got a coefficient out in front. The coefficient is going to work the same way as that subscript or outside the parentheses. We could think of this as having parentheses around it, and again that 3 is going to get distributed amongst everything inside the parentheses. So this 3 is going to count for this entire compound. So when I'm counting my phosphorus, I'd have 3 times that subscript of 2, which would give me a grand total of 6 phosphorus atoms. With the oxygen, I've got a subscript of 5, and again I have to consider that coefficient out in front of 3, so it would be 3 times 5, which would give me a grand total of 15 oxygens in that phosphorus pentoxide. Try one more example. I've got, again, my atoms. Count them as reactants. I'm going to go ahead and identify my atoms. I've got aluminum. I've got nitrogen. Again, I'm taking that nitrate ion and breaking it up into its basic elements. I've got oxygen, and that's it. Again, I'm going to start counting, and I take a look at my subscripts. Here, I look for aluminum, I look at there for my subscript. There's nothing there, it's 1. Again, I've got a coefficient out in front, that 5, so what I would get is 5 times 1, which would give me 5 aluminums. On the inside, I've got nitrogen, which has, again, no subscript. This time I've got a subscript on the outside of the parentheses, plus I also have to consider that coefficient. So for the nitrogen, what I've got is 3 times 1 times 5, which would give me a grand total of 15 nitrogens in this case. And for the oxygen, again, I've got the 3 inside, I've got the 3 outside, and I've got the 5 to consider. So in order to count these, I would have 3 times 3 times 5, which would give me a grand total of 45 oxygens. So that's how you count atoms.